Hey everybody, and welcome to our last lesson about trigonometry. These are our trigonometry applications. We've learned about finding missing side lengths, we found missing angle measures, and now we're going to put it all together and solve some application problems. It's always good to have our friendly reminder of SOHCAHTOA up at the top of your page. That way it's always where we can see it. Helps us remember that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Alright, when we look at application problems, the key to each one of these questions will be to draw yourself a picture, label it with the information given, and then identify what you're supposed to find. When you've drawn a picture, you've labeled it correctly, it looks like any other problem that you've tried to solve before. In this question, it says you lean a ladder 6.7 meters long against the wall. It makes an angle of 63 degrees with the level ground. How high above the ground is the top of the ladder? Let's draw a picture here to kind of illustrate the situation. I'm not much of an artist, so I'll give it my best shot. This will be our wall here, and we can say it's a brick wall here, so we can do some bricks. Okay, we've got a ladder that's leaning up against the wall. So here's our ladder. Okay, make sure we include the rungs. That's important. All right, and then here is our ground. Now, it says the ladder is 6.7 meters, so we'll label that 6.7 meters. It says the angle with the level ground is 63 degrees. I've already messed up because it says it's supposed to be level ground. That's okay. And then this right here, since the ground is intersecting with the wall at a 90-degree angle, that's what allows us to even do this question because we have ourselves a right triangle. Now, how high above the ground is the top of the ladder? Well, this is what we're trying to find. How high above the ground does the ladder hit the wall? Okay, so if you want to, we can redraw this picture outside. Alright. Okay, there's my right angle. This is 63 degrees. This is x, and this is 6.7. Okay. This looks like any other question I've tried before. Alright. From 63 degrees, I've got the opposite and the hypotenuse, so this tells me to do sine of 63 equals the opposite x over the hypotenuse 6.7. To solve for x, we'll multiply both sides by 6.7. Okay, and x now equals about 6.0, and that's when rounded. And don't forget that's in meters. Okay, so that ladder is resting about 6 meters off the ground. Let's try another. Okay, in this example, we've been assigned to measure the height of a local water tower. Let's go ahead and see if we can draw a water tower down here. Here's the water tank, and then here, and since we're in Worthington, we'll make this the Wotown Water Tower. Alright, climbing makes you dizzy, so you decide to do the whole job at ground level from a point 47.3 meters from the base of the water tower. So here you are, you're down here, not wanting to climb to the top, understandably, and you are 47.3 meters away. Okay? Says that you look up at an angle of 53 degrees to see the top of the tower. So from your head, you're looking up at an angle of 53 degrees from the horizontal here. We also call that our angle of elevation if it's above the horizontal. So this is 53 degrees. Okay. Now the one thing we'll also have to account for at the very end here is that your line of sight is 5 feet above the ground. So this distance right here is 5 feet, and we'll account for that later on in the question. Okay. The question asks us to find the height of the water tower. Okay. So here we go. From the angle, I know the opposite, or I'm looking for the opposite, and I know the adjacent. Opposite and adjacent tells me tangent. So I'm going to use the tangent of 53. That's equal to x over 47.3. To solve for x, I'll multiply both sides by 47.3. Okay. And x turns out to be 62.8 meters. Now I told you we have to account for the height of the individual here at the end. Okay, we have found so far from the height of the tower we found until about right here. Okay, we've got to add on the height of the person. 5 feet is approximately 1.5 meters. So we'll go ahead and add on 1.5 meters to our answer there. So we get a grand total of about 64.3 meters tall. Okay, that's how tall our Wotown water tower is. All right, I'm going to let you guys take a try. So this one's going to be your turn. Okay, read the question, draw yourself a picture, label it, and then do your best to find the angle of elevation. Remember that angle of elevation represents the angle above the horizontal, okay, or the horizon. All right, do your best, draw a picture, and then check your answer. All right, so we've got our freestanding tower, the CN tower. Now, since this question has been written, this CN tower has been knocked to the third tallest in the world. It's been knocked down a few pegs. Still a tall tower nonetheless, though. It's 553 meters tall. Okay. The sun is back here, and it's casting a shadow on the ground that is 1,100 meters long. And we want to know what is that angle of elevation. Okay, we're looking for this angle right here, the angle above the horizon. Okay, so that'll be our x degrees. So from that angle, we know the opposite and the adjacent. So we're going to be using tangent. Okay, the tangent of x is equal to 553 over 1,100. Since I'm finding an angle measure, I need to use the inverse tangent. You got to undo tangent. So x equals the inverse tangent of 553 over 1,100. And we find that angle of elevation is about 26.7 degrees. There you have it. You've learned a whole lot about trigonometry applications. Hope you learned a lot through this unit. If you have any questions, see me in class. That's all for now.